Hello students, this is Mr. D'Amico with another algebra lesson for you. Today we are going to be talking about graphing linear inequalities and absolute value inequalities. And if we remember what the inequality signs look like, for example, if we have a greater than or equal to or a less than or equal to, our graph is going to have a solid line. On the other hand, if we have a greater than or just a less than sign, our graph is going to be a dashed line. Let's look at an example and see what we have here. This is going to be a linear inequality, and the first thing we would like to do before we graph it is we would like to put it in slope-intercept form, because that will make it a little bit easier to graph. So we can do that by dividing everything by 2 and getting the y by itself. If we do that, we'll be left with y is greater than 3 halves x plus 5. So then we can take a look and we can start graphing our y-intercept, which would be 0, 5. And then we can count a slope of positive 3 over 2, which would be up 3 and over 2 to the right. And since we're going to run out of room, we can go back to 0, 5, and we can go down 3 and 2 to the left, and then we can make our line. Now, since the inequality sign is greater than, it's going to be a dashed line, and we can see once we get our dashed line, the next option is we have to shade. So when we shade, we take a point on the line. So what we're going to do is we are going to point, let's take that point right there, and we take this point, since the inequality sign is greater than, like it says there, we are going to shade above. So anywhere above this line, so anywhere up here from that point we were just at, if we go up, we will be above the line. So anywhere there will get shaded. On the other hand, if it was less than or equal to, we would shade below the line, but since our problem has a greater than sign, we are going to shade above. So everything above the line there, where those purple lines are, is part of the solution of this linear inequality. Next example, x is greater than or equal to negative 5. Now if you notice there, I circled the x. There's just an x in this inequality. This is a special case. Since there is just an x, that means the graph is only going to cross the x-axis, and the only type of line that will just cross the x-axis is going to be a vertical line. So when I start with my point, it's going to cross the x-axis at negative 5, 0. So I'll start with a point there, and then I can make 2 other points anywhere else on x equals negative 5, because that's going to be the vertical line. This time it is a solid line because the inequality sign is greater than or equal to. And then we have a unique situation here, because usually, as in the previous problem, we would have shaded above the line if it was greater than or equal to, or below the line if it was less than or equal to. With a vertical line, you cannot shade above or below it because it is vertical. So since this is a special case, we have to have another rule for how we shade. The vertical line either shades left or right, and what we do in this case is, if the inequality sign is greater than or equal to, we shade to the right. If it's less than or equal to, we shade to the left. Our problem is greater than or equal to, so we are going to shade everything to the right. Next problem. These are now absolute value inequalities. So this one says f of x is greater than the absolute value of x minus 2. Now if we recall from the last video on graphing absolute value functions, we need to find the vertex. So to find the vertex, we need to see what's happening to the x inside the absolute value bars and what's happening outside of the absolute value bars. So I rewrote this for you. f of x is greater than the absolute value of x minus 0 and then minus 2. So our vertex is going to be 0, negative 2, and we're going to start by making a table, and I like to put the vertex in the middle because if we remember, that's where the absolute value graph changes direction. That's also where the axis of symmetry passes through. That's the vertical line that passes through the vertex. So the next question is, what other values do I pick for my domain or my x? Well, what we like to do is we like to pick two numbers that are smaller than 0, in this case negative 1 and negative 2, and then we can go ahead and evaluate those two domains and see what f of x would be. So we can also, before we do that, we can also list our other two domain values, which would be larger than 0. So we have two numbers smaller than 0, negative 1 and negative 2. And we have two numbers larger than 0, positive 1 and positive 2. Now I'm going to evaluate f of negative 2. So that would be the absolute value of negative 2, which is 2. And then 2 minus 2 is 0. So that f of x value is 0. If I evaluate f of negative 1, I would get the absolute value of negative 1, which is positive 1, minus 2, which is negative 1. Now, if we remember from the last video, instead of evaluating f of 1 and f of 2, since that axis of symmetry passes through the vertex, the other two f of x values are the same as the previous two f of x values. So when x is 1, the f of x value should be negative 1, and when x is 2, the absolute value, when x is 2, the absolute, or the f of x value should be 0. Now, if you can't remember that, you can always go ahead and evaluate. That would be the absolute value of 1 is 1, 1 minus 2 is negative 1, and finally the absolute value of 2, which is 2, and 2 minus 2 is 0. So if you don't remember that shortcut, that the axis of symmetry is like a line of reflection, and the f of x values will repeat, you can just go ahead and evaluate them like I showed you there. Next step is to graph. And graph our points there. The vertex is in blue, and then we can go ahead and draw our lines. This time they're going to be dashed because it is just a greater than inequality sign. And then we have to decide if we're going to shade up or down. So now what we can do in this case is we want to take a look here. So our inequality sign is greater than. So if we pick a point, I'll point to the vertex, and if it's greater than, we shade up. So from this point, if we shade up, everything above this V, everything above these lines will be shaded. So something in here will be shaded because it's greater than. Again, I'm going to start here, and it's greater than, so we go up, and everything above that V should be shaded. There it is, greater than shades up, and there is the shading. Our last example, the vertex would be 6, 1, and I'm going to put that again in the middle. And this time we want to make our other domain values 4 and 5, and then we can make our last domain values 7 and 8. So let's see what happens when we evaluate. X would be 4, and then we can see what y is for the range, because remember, y and f of x are the same thing. They both mean the range. This problem has a y in it, so we can remember that y and f of x are indeed both representing the range. If x is 4, the absolute value of negative 2 would be 2 plus 1. That means y would be 3. If x is 5, we would have the absolute value of negative 1 plus 1, which means y would be 2. Again, the axis of symmetry passes through 6 and 1, so the last two y values would be repeated. 7 should be have a y value of 2, and 8 should have a y value of 3. We're going to go ahead and graph that. Our vertex again is 6, 1. This is going to be a solid line because it is less than or equal to. And again, if I look at my vertex here, this time it is y is less than or equal to. So for less than or equal to, we shade down, which means from this point I go down. Everything below the V, everything down here gets shaded. So the shading will look like this. And there you have it. That is graphing linear inequalities and absolute value inequalities. Thank you for watching, and I will see you tomorrow in class. Bye-bye.